Hello friends, in this lecture I will be discussing with you about two-dimensional arrays. So the one which I have drawn for you is what we call as a one-dimensional array because only one index will be used to travel along or to fetch or transfer all the elements in the array. This is basically a 1D array. Now there are several instances where two-dimensional arrays are used. Now you might have guessed till this point that if I am using one index, then that is 1D array, and in case of 2D arrays we have to use two indices to fetch the elements. And you can see this. This is an example of 2D array. Yes, this is basically what? This is a rack system. And let's say you have kept your book at this location, then how to tell that at what location my book is? So here, if you look, this is row 0, row 1, row 2. So it is in second row. But where in the second row? So it is 0, 1, 2, 3, 4. So fourth column and second row is the place where the book is kept. So in this arrangement, you can see that two indices are required. One, that is I, to know the row number, and second, that is J, to know the column number. And this you have seen in case of your linear algebra or matrices. This is the one. Here, this is your matrix where 1, 2, 3 rows are there and 3 columns are there. It is basically a 3 cross 3 matrix. And here, the indices are 0, 1, 2, and here it is 0, 1, 2. So the rows are labeled as 0, 1 and 2, whereas columns are also 0, 1 and 2. So if I am interested in knowing what or the place where or the index where this element is, then you can see that it is 1, 2, that is first row and second column. And this is a very important thing. So two indices are required. That means row number as well as column number is required. So to declare these types of arrays, that is two-dimensional arrays, let's say I'm having this array A, then I have to specify two things. That is first the row number and then the column number. So this M is the representative of row and this N is the representative of column. Here in this case, 3 rows and 3 columns are there. So how to write elements in it? Let us take the same example which has been written above. So here in the first row, these are the elements. So inside another flower bracket, I will be writing 2.2, 1.7 and 6.2. Once this is over, then comes 2.9, 3.5 and 4.1. Then comes 7.2, 3.7 and 5.3. And in this way, you will be able to, what should I say, initialize the matrix. So this is nothing but two-dimensional array, and you can also see from here. So two flower brackets in the opening side as well as closing side, that means 2D. If there is only one flower bracket or a curly brace, then that means one-dimensional array. Now you can also write this in this fashion, that is 2.2, 1.7, 6.2, 2.9, 3.5, 4.1, 7.2, 3.7, 5.3. Yes, this is the way in which actually the array is stored inside the system. So how compilers knows? The compiler knows because of this particular index array. So what it will do, it will break at this point. It will break again at this point. But in reality, that is how the matrix will be stored inside your system. Okay. Now, this is one way of initializing. The second way is you can use loop also. And important thing is you cannot leave this thing blank in case of arrays. I will show this to you with the help of one example. So let's say I'm having an array, I'm declaring it as int, and this is basically 2 rows and 2 columns. Okay, I'm initializing it here as 1, so 1, 2, and then in the second row it is, let's say, 3 and 2. Okay, now that is how we declare and initialize a two-dimensional array. Now if I'm interested in knowing that what is the element at the 0th location, that is 0th row, and let's say first column. So if you run this, then it is 2. Why? Because this is 0th row and this is 0th column and this is first column. So if you want to know what is the element at 0 comma 0, what you have to do, you have to run it now. So it is 1. Look here. So this is one of the way of declaring an array. Can you leave this row number or this m part? Yes, you can. If you run this now, we'll be able to see there's no problem. Program runs without any problem. But you cannot leave this as such because that is mandatory. Otherwise, it will throw an error. Array type has incomplete element type int. So the column number has to be there. Row you can leave. Okay, this is one of the way of declaring and initializing. Another way is you declare this as such and then you do what? You use loop. How many loops you have to use? 2. Remember, one for row, another for column. So for int I assign 0, I less than, it is 2 now, and then I plus plus, then inside we have to move in columns. So int j assigned 0, j less than 2, and then j plus plus. Then let's say I am interested in printing what percentage d element first, then we'll juggle a bit inside this. So I am interested in a ith row and jth column. So it is I comma j. So if you run this program now, what will happen? It will give you sequentially. So I want that it should print in, or it should, okay, this I have to transfer. So I have to first transfer to the address of this, then I will be printing it. So I have to first scan this up, use scanf, and then here let me write enter percentage d comma percentage d element, and here I will be writing I comma j, and then this, or I have to give some space also. Okay, now then this will be scanned, that means transferred. Okay, so once this is over, let us first run it. So it is saying that enter 0 comma 0 element, let's say it is 1, then it will ask for 0 comma 2. So look how it is moving. First it is moving in the row and then in the column. So that is what I have asked, first move in row and then in column. So let's say it is 2, then 1 comma 0 it is 3, and then 1 comma 1, let's say it is 5. So that's it. That is how we can transfer the elements from the keyboard to an array. Now let's say I'm interested in printing this. Okay, no problem, you can do it. We have to just print. Okay, now here what I'll do is I have to print that element. Okay, so let us say a, and then I comma j, and then here the element is basically percentage d, and it is nothing but aij. So it is aij. Once this has been done, once the j part is over for a particular I, then we have to come to the new line, let's say, or let us bring everything to the new line so that it looks more elegant. So if you run it now, let's say it is 1, then 2, then 5 and 4. So the a 0 comma 0 element is 1, a 0 comma 1 is 2, a 1 comma 0 is 5, a 1 comma 1 is 4. Now if you want to print it as if you are printing an array, then what you have to do, you can write this simply percentage d, give some space, and once the column for a particular row is over, then you can come to next line and then new line. And now if you run it, let's say it is 1, 3, 5 and 6. So it is giving us 0 comma 0. Why it is saying this? Because of this one. Okay, so I have to correct it. Now I'll run it. So let us give some element. Now it is 2, 3 in the first row, 5, 7 in the second row, and 2 and 5 in the first column, 3 and 7 in the second column. Here I am just giving you the number of first row, second row. In principle, it should be when it is indexed, it is 0th row and first row, 0th column and first column, and so on. So that is how you can transfer the elements of an array via a loop. Okay, and let's take one problem. Let's say I am interested in adding up the elements of an array. Let's say I am having this A and I am supplying some elements to it. So in the first row, let's say it is 2 and 3, and then in the second row it is 4 and 1 for array A. Likewise, I can create array B, and in this the elements are 1 and 3 and minus 2 and let's say 5. Now what I am interested in? I am interested in adding these elements. So how to add array? You know, if this is A11, this is A12, or let's say A01, A0, A00, A01, and this is A10, A11, and I want to add this to B00, B01, B10, B11, then what I have to do? I have to add this element to this element and store A00 plus B00 in some another array. Let's say it is C. Okay, and then A11, B01, sorry, A01, and then this is A10, B10, and this is A11 plus B11. So what I have to add in principle? This is what 0 comma 0. So C 0 comma 0 will be this. This is C 0 comma 1. So C I comma jth element will be A I comma jth element plus B I comma jth element. That's it. So here inside the loop, what I have to do is I have to now let us take one more array where we will be supplying all the elements. Again, this has to be of same size. So here C I comma j will be what? Will be equal to ai comma j and then plus bi comma j. Okay. So now once this has been done, so this is simple addition. Now let's say I want to subtract also. Let's say it is d. So here I have to simply say what? Subtract this. That means minus will come. Okay. So if I have to print this, so there's no point. And what I have to do? I have to simply printf percentage d and then space I'll give, and then this is what? This is d basically. So first I'll print the sum. So sum will be c I comma j, and then I will print the difference, that is D I comma j, and that's it. So there is some problem. Okay, semicolon is not there. So now if you run it, you can see the addition. So let me write it like this. Okay, you can understand, I think, from here also. So this is what, this is what, 2 plus 1 becomes 3, and 3 plus 3 becomes 6, 4 plus minus 2 will become 2, and 1 plus 5 will become 6. When it comes to subtraction, 2 minus 1 will be 1, 3 minus 3 will be 0, 4 minus of minus 2 will become 6, and 1 minus 5 will become 4. So in this way you can add and subtract two matrices using C programming. Now when it comes to multiplication, you have to be a bit cautious. Why? Let's say this is A11, A00, A01, A10, A11, and you are multiplying it with B00, B01, B10, B11. Now you do what? How we multiply it? The 0, 0 element of multiplication will be A00 times B00 plus A01 times B10. And then this 0, 1 element will be A00 times B01 plus A01 times B11. Then this element will be A10 times B00 plus A11 times, A11 times B10, and here the last will be A10 times B01 plus A11 times B11. Now if you look this closely, then this is what, if this is going to be stored in this, so this element is what? This is nothing but C0, 0 element, and here this is A00, B00, A01, B10. So 0, 0 element. Okay, remember this first. Then let's say this is what? This is C, first row, 0th column is nothing but A10, B00 plus A11 times B10. So here this 0 and this 0 is nothing but I comma j. This, this, and this. And this is where the multiplication is happening. The same thing here, 1, 0. So this is 1, this is 0, this is 1, this is 0. And here inside the multiplication is happening. So if I am interested in finding out what is C I comma j, that is what? That is A I comma k times B k comma j. I is row, j is column. And here you can very well appreciate the fact that the indices are repeating. And repeating index means what? Repeating index simply means that you have to sum this up. You can also write this thing as sigma, this k assigned 1 to n, let's say. Then this is what? This is I, A I k, and then B k j. And now if you apply for 0, 0, this will be nothing but 0 here, 0 here, and this k will be summed up 1, 2, 3, and if we are starting with 0, so it will be starting with 0. That's it, simple. So in this way you can perform matrix multiplication. So now how many loops will be required? In principle 3 loops will be required. Why? One for row, another one for column, and next one for this summation, this one. Okay, so let us do it. So let us take the same example. So I am having A and B, these two matrices I want to multiply, and let's say I want to save this in C. Now I will be requiring one more variable, sum. Why? Because that is where our inner product, that is for k, will be getting stored. So now two loops are okay. Again I will be requiring one more loop for that addition. For k assigned 0, let us say int k assigned 0, k is less than 2, k plus plus, and inside we have to do this thing. That is, we have to do inner product and store it in sum. So here I will be starting with sum assigned 0, and then inside I will be saying sum assigned sum plus a I comma k, that is what we have written there, times b k comma j. That's it. Once this has been done, then we have to store that into ci comma j, where once this is over, once this part is over, inner product is over, then we have to do this. Okay, that means we have to transfer the value of sum to the elements of C. So after the inner part is over, so basically that C I comma j will be what? Will be equal to nothing but sum. Once this has been done, your program of multiplication is over. So here I have to just print the array C. That's it. So if I run this program, it will give me the answer as -4, 21, 2 and 17. And that is what my answer should be. So let me show this to you. Where is that? Where is that? Where is that? This is the one. So here the first matrix is 2, 3, 4, 1, and the second one is 1, 3, -2 and 5. What I'll do is I'll show this result for this particular element only, this one 0, 0. So here you have to move like this. So 2 times 1 plus 3 times -2. So 2 times 1 is 2 and 3 times -2 is 6. So the answer is -4, and that is what you were getting here. Look, this is -4. Let us do for this one also. So for this one will be 2 times 3 plus 3 times 5. So 3 2s are 6, 5 3s are 15. Okay, so 15 plus 6 will be 21. And what was our answer? It was 21. So friends, in this way you can use matrix multiplication. So what is the logic? The logic is this one. This is the logic. So in this way you can perform your matrix multiplication, and that is how two-dimensional arrays works. So in this lecture, till this point only. In the next lecture, what we'll be doing is we will be diving a bit deeper into C programming, and we'll try to learn about pointers. Very important concept. And from there we will be learning that how to write those functions which are capable of returning more than one values, because you know in C all the function can return only one value, but how to write those functions which are capable of returning more than one values. So in this lecture, till this point only. Thank you very much for watching it.